All right, hello once again. This is Jeff Scott of Rankin Technical College. And as part of the Rankin Technical College Application and Website Development, or AWD 1111, database-driven web development course, I'm doing a series of videos, some review and some will be new, to get us acclimated and ready for the class. I've done about 30 videos so far, and the first 20 or so were on some handbooks or PDF files that were created by Mr. Flavio Copes at his website, thevalleyofcode.com. And I added a few of the presentations that I'd created earlier for a different class, the AWD 1000 Web Development Technologies class, because they talked about some JavaScript concepts. Now I'm on about my 7th or 8th video for Brad Traversy's Web Dev Guide. Again, Mr. Traversy is a self-taught web developer who I have nothing but the utmost respect for. We left off last time right here on Chapter 5. In this chapter, Beyond the Browser, we look at tools to build other types of software such as desktop and mobile apps. Okay, this is a very short chapter, so I'm going to go through this chapter and the next one in this one particular video. So mobile app development, which we have here in our AWD 1112 mobile application development class, can be done in many ways. I have taught iOS apps using Swift at a different college, but here we teach Android apps. The recommendation today is that we gravitate or navigate over to Kotlin, but we've still been using Java here. All right. So notice there's React Native. That's not what we're using. It's a framework that uses React to build apps for iOS and Android. So in other words, not only can you use React to build regular, applications, but you can build iOS and Android applications as well. All right, as it says, it uses React and the React Native Bridge to invoke the native APIs for iOS and Android. What's great about this, according to Mr. Traversy here, is that you build once and your app works on both platforms, both iOS and Android. Flutter is something that's gaining in popularity. As it says, it's a popular mobile app framework by Google used to compile native apps. It uses the Dart programming language, which is similar to JavaScript, although I've never done anything with it. Ionic has been around for quite a while, as has Xamarin, that we'll talk about next. But as it says, it's a hybrid where you can, again, use it to build apps that should work on multiple platforms. Xamarin, I believe at least, is a Microsoft platform. All right. But as it says, it's used for building mobile apps with C# and .NET. All right. Another thing that's becoming in vogue, so to speak, today are PWAs, or progressive web apps. And as it says, these are web applications built with web development technology and that progressive enhancement that we talked about before to give users on par experience with native apps. So in other words, it is a web app that behaves more like a desktop app. Should be responsive, again, have the look and feel of a regular native app, should be secure. It can be installed on a user's home screen and on different devices, and that should be done simply. Now, this manifest, you don't have to worry about this, but I do want to mention for those of you who have not yet taken the AWD 1112 mobile application development class, that we have a manifest.xml file that we work with in using Android applications. Service workers, as it says, are a type of web worker or proxy that sits between an app, a browser, and the network. It's a JavaScript file that runs outside the main browser that can do some work for you in the background. Again, it makes it feel more like a native app. Web Share Target API, never worked with it, but as it says, it allows your web app to register in the same way that platform-specific apps can be registered, so you can receive updates and the like. All right. In addition to mobile development, we now have web developer-friendly technologies to build extended GUI apps. Electron is one of those things I've been wanting to get into for a while and haven't. But as it says, it's huge in the JavaScript world. It's an open source framework used to build cross-platform apps using JavaScript. That's pretty much it for chapter 5, but notice again, I've only been going not even 6 minutes, so I'm going to jump right into chapter 6, which is again a fairly short chapter. Then I will do chapter 7, and I think I'm probably going to fold what's in chapter 8 because that's him talking about mental health and stuff. I'm going to fold that in together. So after this, there'll probably be, I don't know, there might only be one more lecture. So some of the trends in new tech. Web 3. Web 3 is getting a lot of talk. All right. It says, I want to talk about some stuff that is beyond the traditional scope of a web stack developer. Okay. Web 3, it says, there's a lot of hype right now. I do think Web 3 will be huge. However, I do think there's a little bit too much hype right now. The goal here is not to explain in depth what Web 3 is, but to give you a brief overview so you have some kind of an idea. So Web 1 was basically the informational web, where websites were basically, you didn't really do much interaction with them. As it says, they were read-only. In fact, with a lot of things, what happened was you'd have companies that would have like maybe a trifold type of piece of paper that had the information about the company, and people took that and turned it into a website. That's not it, but that's what a lot of it was. Web 2.0, as it says, is the interactive web, kind of where we are right now, where the public creates content, but everything is centralized. And Web 3 is where it's decentralized. As it says, it uses the blockchain, which is discussed next, and you build decentralized apps or dApps. Now, I'm not going to lie to you, I've done virtually nothing with blockchain. But as it says, it is a decentralized, distributed public ledger that is immutable, meaning it's not changeable. It says, think of an actual chain of blocks containing data, and each block contains a number of transactions. Nobody can go in and just magically change data, and it's completely decentralized. So it's not it's not dependent on centralized servers. All right, blockchains run on thousands of nodes. The first major use of blockchain technology was Bitcoin. You probably have your own thoughts about Bitcoin. The advantages, all right, some of them are mentioned here. Okay, ownership of information or data, privacy, security, transparency, and reliability, which brings us into their little talk here about dApps. And they say these are decentralized applications. The concept is still in its infancy. Some of the features, open source. In other words, the code is open to everybody. People can grab it and actually make their own changes to their own copy. It's again decentralized and it's incentivized. As it says, they're typically designed to give users incentives, typically through token rewards, to make them want to use it, want to make it better. And it's also reliable, as there is no centralized server to go off. If the app goes online, as it says, if a node drops, another one will pick it up. All right. Ethereum, I've not used at all. Solidity programming, I know what the concept is, but I have not used it at all. NFTs are non-fungible tokens. You probably have heard about these. A lot of celebrities have created their own NFTs. WebAssembly, another powerful technology that, according to Mr. Traversy, we'll probably see more of. It's a low-level assembly language for the web. Back in the day when you first started to create computer programs, it was done with machine language, which were just the zeros and ones the computer can understand. The next thing that really came up after that was assembly language. It's used virtually not at all anymore, but I'm so old that the first language I used was assembler. And it's not zeros and ones. You use English words, but it doesn't have nearly the syntax and the clarity that languages today have. All right? So when you make WebAssembly, you can write programs in C, C++, and Rust, and especially C and C++. These compile down to their machine language equivalent much faster. So as it says, it allows you to create web apps that are much more performant. They perform better. All right. It says if you're a JavaScript developer, there's a language called AssemblyScript that you can use for this, but it's not meant to be a replacement for JavaScript. All right. All right, it is lunchtime, so I've had some of the other instructors have walked into the office, and that's why I had to pause the video for a moment. I'm not going to talk about PyScript. Artificial intelligence is such a cool thing. There's so many things, there's so many parts of artificial intelligence that could eventually become part of this program. I don't know. It says we saw GitHub Copilot in action in 2021, and that is using artificial intelligence. And supposedly, one of the things with this is it's not even so much that it's going to write code for you, but it'll give you suggestions. That's my take on it, at least. All right. And Traversy says here, since AI can mimic human behavior, we are starting to see a lot more of it in application testing as well. There are also machine learning APIs. There's AI rather all over the place. Dark mode, it says many websites and applications are putting in a dark mode setting. It does involve a little bit of JavaScript, all right, but you can take certain classes, and if dark mode is enabled, you can allow the user to do something they couldn't do otherwise. Voice search optimization, voice recognition is more and more popular. All right, and you maybe have seen stories on this where you get somebody who has suffered a stroke or has some kind of a medical impairment where they cannot speak, and now they're able to due to this, which is kind of neat. Virtual reality is always a big thing. And other programming concepts. I don't remember what I said here, so let me jump in. And we'll keep going. I think we're only at about 15 minutes here. This may end up being the last lecture on this. All right. So in this chapter, they talk about general concepts as opposed to other technologies. Some of these have been discussed already, but they want to look at them. He wants to look at them in a little more depth and breadth of coverage. All right. Now, one thing I like about Brad Traversy, and there's a lot of things, but one of the things I like is not only is he down to earth, but the stuff he says typically makes sense. All right. He says, I've been coding and teaching for a while, and time again, I see people jump into frameworks really fast, but they may pay more attention to the framework and remembering the syntax and don't understand what's actually happening. All right. So in other words, they don't know what's going on underneath the hood. Obviously, as he says, when you start learning any language, you should start with the fundamentals, but you don't stop just because you move on to a framework. All right. So some of the ones, things that he says you should be comfortable with: data types, conversion, coercion, functions, control structures, data flow, input, output, arithmetic, and logic. That's all stuff that makes sense. All right. He says it can't hurt. There are fundamentals when it comes to how languages work in general. This is not as important for web developers, but it can't hurt to learn this stuff. I did a video on my channel called The Programming Language Guide, which teaches about certain levels and languages. I never saw that one, to be honest with you.
I ended up just being the guy doing paperwork.
Just curious as to how long it is.
I knew it just was not.
Hey, what's going on, guys?
24 minutes, so I might watch that and see if I can glean anything that I think would be helpful to us. Object-oriented programming we've talked about. All right, if you've already gone through the C# class, which all of you should have, you've worked with object-oriented programming. It should at least be discussed in the AWD 1000 Web Development Technologies class. But let's keep it simple. With object-oriented programming, you create one or more classes. Classes are blueprints from which you can create objects. Each time you create an object from a class, you are doing what's called instantiating that object. So this is a programming model, as it says, that organizes software design around data and objects rather than around functions. All right, I've already talked about the instantiation. Your classes, you can have properties and or methods. All right, typically it has both. Properties are variables or attributes. Methods are functions. They're the behaviors for your class. Constructors are a special kind of method that runs when you create a new object. All right. The way you create objects is different for every language. JavaScript is prototype based. With that said, though, what has happened over time is with ES6 in 2015, all right, they have made JavaScript prototype based look more like other object-oriented programming languages by changing the syntax in what he calls their syntactic sugar. So you can do stuff like this. And to be honest with you, looking at this, there are a few changes that have to be made. But if I took everything I have here and I put the word public there, all right, and I put, instead of the word constructor, I had the word rectangle here. So public rectangle, and these lets, if I made them ints, basically this could become Java. So that's how similar JavaScript and Java actually can be when you're creating classes. All right. You should be familiar with these terms. I have been on job interviews. Before I came to Rankin, I did a job interview with another local college. It was a phone interview. Evidently, I didn't do well because either they just found somebody they liked better or they didn't like me or whatever. But one of the things they asked me was, tell me the hallmarks of object-oriented programming. And one of the things I said was encapsulation. And they said, give me an example. I said, let me give you a non-computer example. I said, I get up in the morning, get cleaned up, get in my car, get ready to go to work. All right. I never back in my car. My wife, if she drives it, will occasionally back it in. But the point is, since I don't back it in, what I will do is I will get in my car, I will start it up, put it in reverse, and back up. I don't know what happens internally in the car when I put it in reverse and back it up. I don't have to know. It is encapsulated or hidden from me. So as far as object-oriented programming goes, as it says right here, encapsulation in OOP speak refers to bundling data and methods into a single unit known as a class. You have to know the interface for the class as far as if you're going to call something, how to call it, but what happens behind the hood or under the hood, you don't have to know. And again, I've given this example. You've probably seen me do this multiple times. If I go into Calculator and I type in 367 and I hit this X2 thing, all right, that's not the example I wanted to show you. I wanted to show you this one. Nope. Let's try it again. So let me clear and put in 367 and put in, what is it? Is it this? Yes, it is. That's the square root. Do I know how this calculator figured out the square root? I don't know. I don't care. This is my interface. The implementation has been hidden from me or encapsulated from me. The benefits from encapsulation, as mentioned here, include security and hidden data, flexibility, reusability. All right. Algorithms rather, and data structures. An algorithm's a recipe. Now, it's not truly a recipe in that if two people write the same algorithm, all right, it should run exactly the same way, look exactly the same, feel exactly the same. Whereas if two chefs cook from the same recipe, it may or may not taste exactly the same, but the idea is similar in nature. Some popular data structures are linked lists, queues, stacks, trees, graphs, and hash tables. I'm not going to go through any of this stuff now. A design pattern is a general reusable solution to common problems, and there are a lot of them. There is a singleton pattern, which, as it says, restricts the instantiation of a class to one instance. All right, so if you only need one object, the singleton pattern is good. A facade pattern, as it says, it is an object that acts as a front-facing interface, masking more complex underlying code. So for lack of better words, it's sort of like it's a stand-in. It's an understudy. You know, you hear about like a stunt double where it does all the work and the other thing gets the credit. Well, here it's something so you can have a lot of other stuff that's happening behind the scenes. There are other patterns such as the bridge adapter pattern, the strategy pattern, the observer pattern. Okay, I think that's enough on those. Keep your code clean. Write it clean from the get-go. If you've got code that's no longer necessary, if it's extraneous because you've refactored your code, get rid of the extraneous code. Comment while you're putting code in. Don't wait to do it afterwards. Use good naming conventions that are consistent, simplistic, and descriptive. Use camel case. All right. Be consistent always. Class names, as it says, typically begin with a noun phrase. Pick one word, as it says, per concept. Write code like other people will need to read it. Use the KISS principle of keeping it simple. Keep it dry, which means, of course, do not repeat yourself. Comment when comments are necessary. I've mentioned this kind of thing before, and that is when somebody says, do I need to comment this code? Your litmus test should be, would somebody, either you in a future time or somebody who might maintain the code from you later, might not understand why you're doing something. And if they cannot understand it, it probably needs a comment. I've read this book. It is good, this clean code book. And much of it that's in there just is very, for lack of better words, it's common sense. All right, I guess I have reached the 24-minute point. So this management and lifestyle that's in here, I guess I will spend, and I will create one more lecture here and talk about that. And as he says in this chapter, he talks about how to manage projects and as well as lifestyle issues like physical and mental health. So I'll come back with that and finish this up momentarily.